Hello everybody, welcome to a new episode of the Dissenter. I'm your host as always, Ricardo Lopes, and today I'm joined by Dr. Liuba Papeo. She is a tenured researcher at the Institut de Sciences Cognitives Marc Jeannerod of the Centre National de la Recherche Scientifique in France and Principal Investigator of the research program THEMPO, funded by a European Research Council starting grant. And today we're talking about social perception, basically what we pay attention to in other people and their interactions, and the social information we get from that. So, Dr. Papeo, welcome to the show. It's a big pleasure to everyone.
Thanks for having me.
So, when it comes to how we perceive other people, what are the kinds of things we usually pay attention to?
So, attention depends on a number of things. Depends on the salience of the stimuli, so how salient the stimuli are to our eyes. So for instance, a bright red object is gonna attract our attention more than a dark small object. But at the same time, attention also depends on our internal goals, what we're looking for in what we see. And so it's a very interesting balance between the outside world and our internal mental representation. And so in the case when it comes to people, so others, conspecifics, there are the first thing that we attend to are the faces. The research in cognitive neuroscience has suggested that there is a sort of a hierarchy of the things that we care about first, and this hierarchy goes by eyes, face, and then the rest of the body. So, but again, like what we attend first depends on what we are looking for in the outside world. So for instance, if we are looking, for instance, for an object, for an interaction with another person, we might be attending more the limbs, so the arms, the hands, than the face. But generally, a good summary is that, the face and eyes come first.
But when we look at other people, and later on in our conversation, we're going to get into more detail in terms of, for example, when people are facing one another, or in terms of how they present themselves in relation to one another, what kinds of things we pay attention to, and what kinds of informations we get from those kinds of, let's say, interactions. Are there, generally speaking, are there particular kinds of information that we are looking for when we perceive other people either in isolation or in interaction with others?
We pay attention to a lot of things because we care about a lot of things, but we can synthesize these the features that we care about in two categories. One is those features that help us to understand who is the other, who the other is, who are you. And the others are the features that help us understand what are you doing. Mm-hmm. So there are these two aspects of another that we consider very important for our immediate behavior and also for our survival. So when we look at another person, we are very efficient. Our system, our visual system, is very efficient at extracting a number of important pieces of information that allow to, for instance, decide or establish surely the gender, the age. We are very sensitive to the cues that suggest the age of our of the other, the origin, the race. There is a full line of research suggesting that there are very subtle ways in which difference in the race of the others affect our behavior. Of course, also we can extract information from just the visual appearance by just looking at the others. We can extract information about the status. For instance, how dominant the person is in the social hierarchy, and the state, so the mental state, the mood of the person. There are beautiful experiments showing that just by looking at the motion pattern, so the way in which another moves, we are very accurate in determining their emotion, whether it's happy or sad, and so on. And this is, the category of features that I define as those that allow us to understand who the other is. But then there is another set of features that we are very good at processing and extracting from visual information, from just looking at the others, which are the features that allow us to understand what the other is up to, what is about to do. And these features are especially important in the context of social interaction. So it's very important to observe the others interacting between each other, with each other, to extract a number of features that allow us to understand again, his role in the society, in a specific context, but also more generally, whether a person is in the social hierarchy above or below the other person, the level of intimacy, the social distance, and also from the way in which two interact with each other, we can immediately understand with a very fine sensitivity to the motion patterns, the way in which people move and interact with each other, whether they are in a friendly relationship, whether they're sharing the same goal or they're competing, whether they're helping each other, and so on. All this information comes out of almost a first glance to the others.
And by the way, you mentioned several different things there, like, for example, people's race or ethnicity. I mean, do we know to what extent some of the things or the kinds of information we want to acquire from other people and the kinds of things and behaviors we pay attention to, if at least to some extent they are culturally learned? There is, I mean, my paying attention to one person's ethnicity is something that I learn culturally to pay attention to, or if all of these things, or at least a few of them, are sort of quote unquote innate. There is even newborns already pay some attention to some of these features and behaviors. What do we know exactly about that?
So that's a very interesting question that has been the subject of research for decades. And of course, there are many unknowns, many things that we don't know yet. But certainly, we can say that humans are born with an innate, or at least very early, when I say early, I mean within hours from birth, ability to recognize faces, to detect a specific kind of motion, which we call biological motion, and that's the specific way in which biological entities moves that is very different, for instance, from the mechanical motion. Humans are also born with a very early capacity to attend to the other's eyes and know where the others are looking at us. So when we are being addressed relative to when the others are looking somewhere else. And we also have a very early an efficient capacity to follow the other gaze. So to know, that's one of the first things, maybe the most important thing that we look at when we process others, where they're looking, which anticipates or predicts what they're going to do. So if they're looking at me, this is probably a signal, a very strong signal of social engagement, is looking for social engagement, is looking away, okay, where he or she is looking. So these are the things that infants within hours or days from birth are very sensitive to. And we share many of these processes, many of these mechanisms that make us so efficient in processing socially relevant stimuli with non-human species. Like we have seen similar behaviors, very early behaviors in various species of monkeys, but also in chickens, for instance, or in species that are farther away from us. Then there are other aspects, as you asked about the race or the age. There are other aspects that emerge relatively early. So there is, for instance, this phenomenon known as the other race effect, which refers to the basically very early sensitivity to people, to individuals who are from a different race than ours. There is something similar, for instance, in speech perception, this early sensitivity to differentiate between speech sounds that are from our native language and speech sounds that are from another language. For instance, Indians have some sounds, some phonological sounds that we don't have, like the der, the ter. We don't have these sounds in our language. And very early on, infants are capable of discriminating between the sounds of their native language and sounds from other languages. But this kind of, sensitivity to these more culturally determined differences seems to be the result of a learning process which operates very rapidly. Again, within months from birth, infants can make these subtle discriminations. But it's because when they are born and they're immediately immersed in a very rich social environment, and so they immediately pick up the features that are typical of their native social environment and immediately become capable of distinguishing those features that are very important from their integration in their own society from features that don't belong to their own cultural group.
So in my first question, one of the things you mentioned that people, and also infants in this case, pay lots of attention to is the face and particular features of the face, like the eyes, for example, eye gaze. Apart from eye gaze, what are some of the other features of the face that people tend to pay attention to, and what kinds of information do we get from that?
The human ability to process a face is impressive. I would say that there is nothing that is so efficient, so tuned than the human ability for face perception. So just by looking at a face, we, as I said, we are able to, first of all, immediately recognize the identity and discriminate between the two faces, even when there is a lot of similarity. There are again two different aspects, two different categories of features that we extract. One category is what allows us to identify a person. So, as I said, to categorize a person in terms of gender, race, age, and if we know the person, also immediately assign a name to that person, an identity to that person, and so immediately retrieve all the knowledge and information that we have about that person. This This is a very rapid, very efficient mechanism. And then there is another family, another set of features that allows us to establish, to process the actions of the face. And in the case of faces, actions are manifestation, often manifestation of two things. One is the communication. So by looking at faces, just the way in which the face moves is very important for speech perception. For instance, we know that if we have access to the face of the speaker, our speech processing, so our ability to process and to understand what the speaker is saying, is much more efficient. And there are a lot of interesting phenomena that show that, in fact, the facial movements can affect also the acoustic signal, the acoustic information, what we hear. So if I show a movement of the lips that is not compatible with the sound that I'm producing, that the speaker is producing, and there are very nice experiments that manipulate the mismatch between the lips movement and the sound, you see that we perceive a distorted sound, which means that what we see in the movements of the face affects what we hear. And also the second type of action information conveys information about emotions. We know that we have a very rich repertoire of facial actions that convey as well a rich set of different emotions. And so these two families, like the features to define who a person is and the features to define what the face is doing, is trying to communicate, of course are tightly related, but can also be dissociated. And when I say dissociated, I imply that they are actually features that are processes in partially different parts of the brain. Of course, very strongly integrated.
So now I would like to ask you about something very specific that I read about in your work. What is facing-dyad perception, and does it relate in any way to face perception?
So for many years, for many decades, cognitive neuroscience has studied, of course, we have this very strong and understandable interest for social perception, social cognition, how we understand, how we recognize others. But for many decades, these questions have been addressed by studying the perception, the processing of individual faces, individual bodies, individual movements. Until when researchers, including myself and the people working with me, decided to study what happens to all these beautiful mechanisms that I've been talking about to process faces, motion, bodies, when instead of seeing one face, one person, you see two people together. All this sensitivity, all this tuning to all these features is preserved, or there's something else that happens. And what we have seen, so the main interesting result that we found when we started asking this kind of question was that, as I said, the faces are very special to our visual system and to the whole brain, because they are fundamental to understand, interact, recognize others. But what we saw is that when we see, instead of one face, two faces, all this very efficient processing is preserved, particularly when the others are perceived as if they are interacting. which means face-to-face. So we did a very simple experiment. We were studying, the efficiency of visual recognition of multiple bodies. And so we presented pairs of bodies in different spatial configurations. And we soon realized that subjects were particularly efficient at recognizing multiple bodies, as efficient as they are at recognizing one face, when these two bodies are put face to face relative to when they are in any other configuration. And so that was the first insight, the first piece of information that suggests to us that there might be something really special in the brain about the perception of what we call the facing-dyad. Now, why the facing-dyad? Why two people face-to-face would be special to our visual system? Well, this is an open question, but the intuitive response is that this configuration, when we put two people face-to-face, this is the prototypical configuration of human social interactions. So when we interact with others, we privilege this face-to-face positioning because this face-to-face positioning gives us access to the other's eyes, to the other's face, full face, so we can extract information about emotions. And also it gives us access to the whole body. So it's the perfect viewpoint to have as much information as possible from the other, and so to facilitate interaction. And so the idea is that this facial configuration, this face-to-face configuration of body is so important for our social life and so redundant, so recurrent in our social environment that the human brain has developed a mechanism that makes the processing of these two bodies especially efficient. And this is confirmed by, if we look at the evolutionary psychology literature, people have studied how often humans spend, how much time humans spend in certain, spatial positions relative to each other. And they've seen that not just humans, but also monkeys and probably other species spend more than the 50% of their time in social interaction facing another, so face-to-face with another. And most of the time, the most frequent composition involves two people. So face-to-face, dyadic interaction seems to be an important, a recurrent structure in our social life, in our social world.
So this is already, I guess, one aspect of studying social scene perception, right? And one of the things associated with that, or a concept, I guess, in this case, is minimal social scene. So what is that concept really about, and what can you study through it?
So it's this idea of minimal social scenes refer to what I've just described. So when we started this research, we wanted to isolate, to get really like we see a lot of interactions, all kind of actions that people perform on each other or with each other. People act in dyads, in groups. We have crowds of people doing things together. So the social interaction, the range of social interactions possible social interactions is very broad. But we wanted to get to the minimal unit. What if we remove all the unnecessary features and we get to the core structure of a social interaction, what remains? And what remains is this two-body configuration. So this configuration that involves two bodies or two faces, in general, two people, two social agents, facing closely like in spatial proximity and facing each other. So, and this is really like, so we decided to study this configuration of two bodies, this facing-dyad, just like we have studied other objects in visual perception. Just like we have studied faces, we have studied bodies, we have studied any other object in the world, we consider this a new object of visual perception, this configuration, which is the early rudimentary representation of a social interaction.
And so we've talked earlier about how people interpret when they see someone or a dyad of people facing each other. So apart from facing each other, what are perhaps some of the other kinds of cues that people take in when distinguishing between an interacting and a non-interacting dyad in crowds, for example?
Yeah, so we have, again, just like in the case of face perception, we are now, this is a very recent line of research that is really considering this new object of social perception, which is not one body, not one face, not one action, but two people together. And so we are now discovering all the information that is rapidly extracted from these stimuli. And so, as you said, one is the relative positioning, what we call the facingness, where they are facing each other or not, or they're facing away from each other. But there are another, a large family of a large set of cues that we think and research suggests that are really relevant to initiate the processing of social interaction. Some of such cues are, for instance, as I said, the spatial proximity, how close in space two people are, the touch, whether they are in contact, they're touching or not. So others are the mimicry, whether, you know, their body postures or their facial expression look alike, which means that, which is a feature of the social interaction. When we interact with someone, we tend to have this automatic mimicry of their behavior. And we can see from outside when two people are interacting, they tend to imitate themselves. They tend to coordinate or to synchronize. So coordination, synchrony, mimicry, distance, openness, like typically people that are interacting have this posture that is open toward each other. And these are very measurable things. We can take, you know, photos of interacting people and really measure all these things. And this is exactly what scientists are doing right now. First of all, to understand which are the properties, the features of an interaction that we process, that we extract, from which we make inferences about the social relationship between two people. But also to understand whether there is an hierarchy between these things. So what is the relation between these things? We don't have the answer to this question yet, but, you know, intuitively, one may think that if two people are face to face, they're probably interacting, or this is what our brain spontaneously would think. But you know, if you start manipulating the distance, so you increase the distance between them, probably the effect of facingness starts, you know, diminishing. So, and it would be interesting to see at which point the distance breaks the effect of facingness, whether it does it at all. So basically, this is the kind of questions that we are now asking to understand how, because that's the thing. The question is not whether we understand social interaction and what we understand about social interaction, because we do understand social interaction. We are very rapid at, you know, understanding what kind of relation there is between two people just by looking at these people. And we understand a lot of things. We can extract all kind of information just by looking at how two people interact with each other. But the question that we're trying to answer is how we do it, how our brain does it. So this is why it's important to understand, okay, what are the basic cues that the visual system extracts from the structure of the input, from what we see outside, that starts this process that then leads to a full understanding of a social interaction.
And of course, it's very interesting to understand or know what these basic cues are. I mean, the basic kinds of things that people pay attention to in the social scene to perceive and interpret how people relate to one another and what people are doing that is socially relevant there. But I would imagine that something that is also very interesting to understand is, of course, we do this in the split of a second. It's lots of information, but we process it very, very quickly. But at the same time, I mean, it's not like isolated cues, but we are sort of taking it all in at the same time. I mean, it's like several different cues that we process very quickly, right?
Yeah. So that's you know, of course, the result of this process is extremely impressive. As you said, in a few tenths or hundreds of milliseconds, we are capable of, you know exactly who you are, what you're doing, and what's your relationship with another. If you think about it, it's pretty impressive. Now the question again is how the brain does it. So we're a little bit like farther away from an answer to this question. For two reasons, as I said, like we know a lot about face perception and body perception and biological motion perception, and that's a good basis, I think, to start this enterprise of, you know, understanding how we understand our complex social world. But you know, there are questions that are, because of course understanding what the others are doing and how they relate to each other also requires to understand what they have in mind. So understand their goals, their intention, their motivations. And these questions fall under the big umbrella of social cognition, social neuroscience. And this is a very young enterprise. We have begun asking this question a few years ago. And there is a lot of effort and a lot of energy, a lot of resources now that are dedicated to this kind of research, mostly because it's clear that the society that we are building, that we have built and that we are building, relies on our ability to manage people, to organize group of people, to understand how people relate to each other. So to be able to sustain this kind of social environment that we live in, we have to understand as much as we can about the human social brain. But again, this is a very young enterprise, and so most of the questions are still open to discussion.
Mm-hmm. Right. So, and since we're talking here also about the brain, of course, and we are referring mostly to spatial information, spatial cues. They are processed, of course, by the visual system. And is it the case that socially relevant spatial relations are represented visually differently than stimuli that are just unrelated or appear unrelated to one another?
Yeah, absolutely. So this is basically the one of the main findings of our research in the recent years. As I said, we have first found initial evidence in our empirical data, our empirical results, suggesting that facing individuals, which is a proxy of social interacting individuals. So when I say facing, I'm implying that this positioning is somehow suggesting to our brain that these two people are interacting, and this is why it's so important for our brain. So as I said, we have found that facing individuals are processed more efficiently than the very same individuals in a different spatial relation, and we have begun to show that the very specialized mechanism that we have learned to appreciate in face perception also apply to this configuration of seemingly interacting bodies, so face-to-face bodies. And then we have found, I use a lot functional MRI, which is a neuroimaging methodology that allows to record the brain at work while it's working. So to look into the brain, to measure the brain activity during any kind of cognitive task. And so using fMRI, we have seen that in the visual areas, so in the areas dedicated to face, body, biological motion perception, the very same bodies, so the very same bodies are processed differently when they are face-to-face relative to when they're back-to-back. And this is pretty impressive because so we just had the stimuli with the two bodies either positioned face-to-face or identically just flipped so that they look back-to-back. So from a visual viewpoint, these two stimuli carry exactly the same information, the same amount of information. It's exactly the same number of pixels, the same body shapes, the same postures, the same color, brightness, all the visual information that you think of. But just the fact that they're face-to-face, they're positioning to face each other or facing away from each other, drives all kinds of different effects in the visual cortex. So for instance, the visual cortex, in general, the level of activity in the areas for face and body perception is significantly higher. So the regions respond more when the bodies are face-to-face relative to when the two people are back-to-back, which is already, I think, very interesting. But also, for instance, we have found using more sophisticated analytic methods on fMRI data that the representation of each individual body is more accurate, so the brain represents each individual body better if the body appears in a relation, in a social relation with another, than when the body is presented in isolation. So yeah, the short answer is that yes, there is something special, and when I say special, I mean face-like special, in a sense that, so as I said repeatedly, is like a face perception is the gold standard of the efficiency of human visual perception. And so what we see is that some of these very efficient mechanisms that we have developed to process faces are used to process interacting people.
And so, still about perception, there's something very specific that I haven't asked you about yet. So, what is body form and body motion perception, and in what ways exactly do these specific kinds of perception contribute to processing social events?
So these are body form and body motion are the two fundamental components of that the visual system uses to build representation of an action. So to understand another's action, so what another person, for instance, is doing, but it's true also for the action of animals and also for the movements of objects, we need to extract information about their structure. So, for instance, in the case of a person, how the various body parts are positioning with respect to each other. So if the hand is here or here, this defines a different body posture, so a different body shape. So this is the body form information. And then there is the other side that is the motion. So how the position of each part changes from time to time, and this defines the motion pattern. So these are two different aspects that then they are integrated. So these are the body form and or body shape and the body motion are dissociated, different processes. Also because they are implemented, they are computed in different parts, in different brain regions. So we know that these are two different aspects. But of course, the regions that care about body motion and the regions that care about body shape work in sync, work really like in a close interaction with each other. We say that they are functionally connected because the information needs to be integrated to deliver the representation of an action, which is the beginning of the process for action understanding. So we first need to understand the body posture, the body motion, and from there we can start all the inferential processes that allow us to understand what the other's action goal is, what the intention of the others are, and this is what we call the social inference.
By the way, body form and body motion perception, are these in any way forms of embodied cognition?
So, no, these are visual processes. So the idea of embodied cognition, the general idea of embodied cognition is that much of our cognitive life depends on our experience in the environment. So it's based on, in particular, our motor experience. Mm-hmm. So, but when I talked about body form and body motion, I was referring to visual processes, like the processing through we extract information from the physical structure of the input. Now, does our experience, our action, motor experience in the environment affect the way in which we process other actions and social interactions? So we know that there, of course, like we are in bodies. Like the brain is integrated in a body that has a certain type of experience, and the way, like our history of interaction in the environment affects how we perceive other actions. There is a very rich and complex literature on this, relationship between action understanding and the motor experience. We know much less about how our experience of social interaction, so of interacting with others, affect the way in which we understand others' social interactions. I think there is no really like a fully developed line of research yet on this. But, there are a number of non-trivial questions to ask. For instance, the idea is that when I observe another performing an action, in order to understand, that's the basic idea of embodiment, to understand what the other is doing, I need to sort of use this as a simulation process. I have to internally simulate the same action, and this allows me to understand what the other is doing. But now, in the context of social interaction, I'm observing two people or more people interacting with each other. So how does the motor simulation work? Like, can we simulate multiple actions at the same time. So there are more people interacting. Our motor system is busy at, simulating all these actions simultaneously. We are not sure the motor system can do it. We are not sure the motor system can hold the representation of multiple motor programs at the same time. And we can think, maybe the visual system selects the most important, of two agents, and this is what it follows. There is research that shows that we are very good at detecting in an interaction who is the agent and who is the patient. So who is the one who is acting on the other, and so and we know that. The system, the brain, privileges information about agents. So one possibility is that the motor simulation also privileges the simulation of the action of the person who is recognized as the agent. But again, these are all possible solutions, but we don't know the answer yet.
But at least potentially there's some space for embodied cognition here.
There is always a space for embodied cognition. It's a very interesting angle to look at how human cognition in general, by relating the mind and the brain to the rest of the body. This is absolutely interesting because, as I said, cognition doesn't happen in a vacuum. We are in a body, and what happens to our body certainly affects our brain and our mind. But I also have a very critical view of embodied cognition because I think there are a lot of things, a lot of representations that don't depend on motor experience, on our experience, are totally independent from motor experience. And so sometimes I tend to be a little bit critical toward the views that want to reduce the whole human cognition to motor experience.
Mm-hmm. So now I have a couple of questions that I think you've already at least slightly touched on them earlier, but when it comes to social representations, is the social entity itself as important as the relation that binds multiple entities together, or not?
So, yeah. I think the relation is all that matters in the social life, in for social cognition, and to the point that when we perceive a relation between two social agents, between two people, the brain creates a whole new representation that has almost nothing to do with the two people itself. What I mean, and we have shown it really empirically. So when we see two objects, the neural response to the two objects seen simultaneously is typically a linear combination of the response to the two single objects. So we can, from the response to the two objects together, we can retrieve information about the two single objects because the information about the two single objects is maintained in the representation of this composite representation that involves both objects. So if I see a pen and if I see these two objects and I measure the response to this first in the brain, and then I measure the response to this in the brain, and then I measure the response to them both presented together, this response is typically an average or some linear combination of the response to the two single objects. But now what we see is that when we see two people, and these two people are represented in a social interaction, the response to these two people is a non-linear combination of the response to each individual body presented in isolation. And this non-linear combination of the response to the individuals is an indication that the brain is building a new representation that has almost nothing to do with the individuals. And this new representation is basically the core input for the social cognition system. So yeah, the relation is perhaps more important than the individuals themselves.
And the relation is almost, or perhaps it is even a different entity or a different kind of representation than the two individual people and even the two individual people interacting with one another. I mean, it's a thing in and of itself, right?
Yes, that's again, I was too enthusiastic in my yes, but that's my guess at the moment. Yeah, we have empirical data using fMRI, using electroencephalography that can isolate this integrative response that suggests that the brain is transforming the input into something that is a new thing that has nothing to do with the input itself. And we have seen this signature of integration a lot when it comes to the perception of social interacting people.
And when it comes to the brain, do we know if there's actually visual specialization for dyadic human interactions? I mean, is there specialization for that specifically or not?
Yeah. Absolutely. As I said, we have recorded using fMRI, we have recorded from visual cortex, from visual regions, and we have seen that there are some very selective parts of the visual system that seems to like facing dyads more than anything else. So this is already one signature of specialization. We have seen even in behavioral tasks, like if we present stimuli around the perceptual threshold, so in very low visibility conditions. So we are used to do this experiment to isolate the limits of visual perception. And so we present stimuli, for instance, low contrast stimuli very rapidly to the subjects, and the subject have to report whether they've seen a stimulus or not. And we see that, and this is one of the ways to measure the efficiency of in the perception of a given type of stimuli. And what we see is that, again, when we present these facing bodies, the system is much faster, so the responses are much faster and much more accurate than when present bodies in isolation or in other kind of spatial relations. So we have a behavioral, we have fMRI, we have EEG, electroencephalographic signature that suggests that there is a visual specialization for facing dyads. And visual specialization means that we just have very efficient mechanisms to detect this kind of configuration in the space. So for instance, if I present subjects with a very cluttered and rich and noisy visual scene that has two facing people somewhere in this scene, we have seen that subjects immediately find this stimulus in the clutter, and this is, and again, another signature of a visual efficiency.
So earlier we've talked about the kinds of cues that people process in looking at a social scene and interpreting it as, for example, when looking at a dyad of people, as interacting or non-interacting. But how do we go from spatial relations between people to perhaps trying to extract some information about the kind of relationship they have with one another, and how much information can we extract from that, about that?
So as I said, unfortunately, I cannot give you an answer about how, because we are just at the beginning of this enterprise. So maybe in a few years, we'll be able to know how we go from, putting together, so the visual system knows that the two people are face to face, they are close in space, they are touching each other maybe, they have outstretched limbs toward each other, so they have all these features, so immediately the visual system represents, okay, this might be a social interaction, and so this information package is sent into the high-level networks for social inference, the so-called social brain network. And from here, how do we come to understand, for instance, that these two people are two lovers, for instance, or are two enemies, are competing? It's less clear. What I can say is that, again, we are very sensitive to small variations in the spatial temporal patterns. So, for instance, the way in which one object moves with respect to another can be immediately interpreted as having a positive or a negative intention. So, and if you just a small acceleration in the movement of an object relative to another object can suggest that one is chasing the other, or that it's one that is chasing the other, or that the other is escaping from the other. Like a small variation in the acceleration, for instance, can give a completely different cognitive representation, mental representation of what we see. But again, the computational machinery that does this, from seeing bodies, faces facing each other, especially close to understand the rich nature of a social interaction, that's really an open question.
Mm-hmm. And do we have a good idea of what are the areas of the brain that are part of the network that processes social information?
Yeah, I mean, we do. So definitely there is an important contribution of visual areas. As I said, we have been discussing this so far, like visual areas extract of a lot of useful information for social inference. And I'd say that because of the importance of social life from our survival, we have developed a number of very efficient mechanisms to do so. So visual mechanisms dedicated to extract socially relevant information. But then outside the visual system is just the entry of the information in the brain, and outside of the visual information in the brain, but then outside the visual system, there is no one network. There are many networks that implement processes that are relevant for social cognition. For instance, the action understanding network is the network dedicated to understand the action, and what understanding an action means understand the goals and intentions of an action. There is the theory of mind, or the mentalizing network, which is another set of regions that is dedicated to what we call mind reading, what's in another mind, what the others are thinking. Also, we are very good at that, and we don't know how that happens. And then there is, of course, the semantic system, the conceptual system that represent all the knowledge that we have about the others, and in particular the social knowledge seems to be a very specific type of knowledge that is represented probably in dedicated part of the larger semantic system. So yeah, what we need to understand is really the specific computation in each of these regions, and also how the information travels within these networks and how these networks interact with each other. Let me just add a last thing. I talked a lot about visual information, socially relevant visual information, because that's what I study. But there is not just vision. There are other sensory modalities, and the other sensory modalities carry also a lot of relevant information for social cognition. As we talked about briefly about speech, the acoustic signal, there's nothing more social than speech. And the smell is another field that is receiving a lot of attention because it's probably one of the fundamental foundations of, it provides some foundations to social relationships. So It's going to be a long way.
Yeah, of course, it's important to mention that we here today we were focusing on spatial relations and on visual information because that's the main focus of your research. But of course, we do not only process visual information, but also information from the other senses when interacting with other
Right.
people.
It's important. It's important to say so. Also, not just because it's fair for our colleagues who don't study vision, but also because vision is one of the most, if not the most, studied aspect of the human brain, and some believe that vision is also the main sensory modality for humans. Some agree, some don't agree with that, but it's true that we have a representation of the brain that is very much centered on visual processing, but it's fair to acknowledge that there are other important modalities and fields of research that needs to be acknowledged.
Of course. So let's get into our last topic/question. So we've been focusing on humans here, but what about non-human animals? Because I mean, we as people, I guess that we also look at the spatial relations, body configurations of other animals. And for example, there are some biped animals and some quadrupeds as well. So do we distinguish in specific ways between those two, and how does that work on the level of the brain neurologically?
So there are two aspects of this research. I'm trying to answer them both. The first one is our perception of other animals that are non-humans. The mechanism that I described, the first general answer to the question is that all the mechanisms that I described so far, like this ability to process faces, biological motion, bodies. So this is why I talk about faces, biological motion, bodies, and not human bodies, not human faces, non-human motion, because these, especially in the visual cortex, the regions that care about this important aspect of the social life, recognizing faces, bodies, motion, operate over any animate entity. So they don't seem to care much whether a face is a human face or a monkey face. For instance, the fusiform face area, which is the region that responds to faces, that has this very strong selective response to faces, doesn't show a very reliable difference between a human face and a monkey face or a cat face. And the same is for the regions that process motion. They process biological motion, so any kind of motion that looks like has the property of a biological motion relative to mechanic motion. But they don't have much fine-grained distinctions in terms of, the species that is moving, whether it's a human or not. So in one line of research, we really asked the question whether the visual system really doesn't help at all in the distinction between human and non-human animals, which is very important for us. I mean, we need to know whether an animate thing is a human, is a conspecific or not. And I was very particularly surprised by the research on biological motion, because it was a little bit confusing. Like most of the field was talking about biological motion, but some authors were talking about, these regions being attuned to human motion. So I wanted to see whether they are really tuned to human motion, which means that these regions are capable of distinguishing what is human from what is non-human, or in fact they are picking up some feature in the motion that is typical of humans, but they don't really recognize what is a human and what is a non-human thing. So the intuition, the idea that we had was, okay, we can present videos of four kind of animate entities. A walking man, just a human who walks, another human, a baby, crawling, quadrupeds, 4 legs crawling, and a cat is a non-human, which also walks with 4 legs, and a chick who is a non-human, but like the prototypical human, walks with 2 legs. So we wanted to see whether the regions in the visual cortex that care about motion could really distinguish human from non-human, in which case we should see that response to the man and the baby is more similar than the response to the cat and the chicken, or they are not really human preferring regions, but they actually only care about motion. And so what they can distinguish is the kind of motion, and they don't care whether it's a human or non-human. And because there are these 2 big categories of motion, bipedal motion, which is typical of the human species, but not only of the human species, and quadrupedal motion, we predicted that if these regions only care about the kind of motion, we should find that the response to the man is more similar to the response to the chick, because they are both bipedals, and the response to the cat is more similar to the neural response to the baby, because these are 2 quadrupeds. They're moving with 4 legs. And this is exactly what we found. So this means that, yes, what this means is that, yes, the visual system is capable of making distinctions, a subtle distinction, in this case in the type of motion, which might be useful then to distinguish what is a human from a non-human, but they are not yet representations of humanness. The visual system doesn't seem to care much about humanness. It cares about animate things, animals, whatever is a biological entity. Of course, you can find the differences, for instance, because, I don't want to, colleagues to jump and say, no, but also, the response to human faces in the visual system is stronger, but then it becomes hard to know whether it's just an effect of familiarity, because we see a lot of human faces, and we have seen very few monkey faces in our life. So you can pick up this difference due to the familiarity of the stimulus, to which the visual system is very sensitive, but it doesn't mean that intrinsically the visual system care about the human-non-human distinction.
And I guess that one very interesting thing about studying these and how the brain processes information, motion information and spatial, and the information about the body and spatial relations between humans and non-humans, is that these might also inform us about whether specific areas of the brain are specialized for processing human-related information, or if they are perhaps more domain general and they are specialized just for motion or for particular body configurations or something like that. Right.
Yeah, so the kind of manipulation that I described, where we manipulated the motion in the bipedal versus quadrupedal, human versus non-human, is one example of the kind of manipulation that we do. And this is why it's fun to be an experimentalist, because, we have the brain activity, but then we have to read the information in that activity. So we can use this kind of manipulation to see, okay, what's in that activity? What's the information in that activity? Is information about a species, a human versus non-human, is information about motion, so bipedal versus quadrupedal. And so in this way, exactly with this manipulation, we found that in fact these regions in the visual cortex really care about motion. That's all they care about. But there are other regions in a higher level, in higher order systems that instead begin to make the distinction between a human and a human, because our cognition needs to make that distinction.
Great. So, Dr. Papeo, just before we go, would you like to tell people where they can find you and your work on the internet?
Yes, so I have a website, a personal website, I'm learning French, so it's like
That's okay.
it's terrible. So www.liubapapeo.com. I'm also active on Twitter as Liuba P. I have recently joined this Blue Sky platform now, website, which is gathering a lot of scientists around the world, where we have very interesting discussions. And or you can always reach me by email. My email addresses are available on my website and my institutional website.
Great. So I'm leaving links to all of that in the description box of this interview. And thank you so much again for taking the time to come on the show. It's been a pleasure to talk to you.
My pleasure. And thanks for having me again.
Hi everyone, thank you for watching this interview until the end. If you like what I'm doing, please consider supporting the show on Patreon or PayPal. You can find the links in the description box down below. And if you like the interview, please share it, leave a like, hit the subscription button and comment. This show is brought to you by Enlights Learning and Development Done Differently. Check their website at enlights.com. I'd also like to give a huge thank you to my main patrons and PayPal supporters: Pererga Larsen, Jerry Mueller, Hans Frederick Sunder, Bernardo Seixas, Olaf Alex, Adam Kessel, Matthew Whittingbird, Arno Wolf, Tim Hollis, Henrik Alenia, John Connors, Philip Forrest Connolly, Dan Demetri, Robert Windiger, Rui Inácio, Zup, Marco Neves, Colin Holbrook, Phil Kavanagh, Michael Stormer, Samuel Andreev, Francis Ford, Tiago Nunes, Fergal Cusson, Harl Herzog, Nuno Machado, Jonathan Librant, João Linhares, Stanton T, Samuel Correia, Eric Hines, Mark Smith, João Eira, Tom Hummel, Sardas France, David Sloan Wilson, Yossi Lades Araújo, Ruben Roach, Diego Londonio Correia, Yannick Punter, Adana Rusmani, Charlotte Bliss, Nicola Barbaro, Adam Hunt, Pavel Ostaszewski, Nelek Bach, Guy Madison, Gary G. Hallman, Sam Afzal, Adrian Yegi, Paulo Tolentino, João Barbosa, Julian Price, Edward Hall, Edwin Bronner, Douglas Frey, Franca Bortolotti, Gabriel Ponce Cortez, Ursula Litzke, Scott, Zachary Fish, Tim Duffy, Sonny Smith, John Wiseman, Daniel Friedman, William Buckner, Paul George Arnaud, Luke Loaki, Georgios Theophanous, Chris Williamson, Peter Wolozin, David Williams, Diogo Costa, Anton Erickson, Charles Murray, Alex Shaw, Amaury Martinez, Coralie Chevalier, Bangalore Atheists, Larry D. Lee Jr., Old Herrigbon, Starry, Michael Bailey, Dan Sperber, Robert Grassi, Zigor N., Jeff McMahon, Jake Zool, Barnabas Radix, Mark Campbell, Thomas Dobner, Luke Neeson, Chris Story, Kimberly Johnson, Benjamin Galbart, Jessica Nowicki, Linda Brandon, Nicholas Carlson, Ismael Benzliman, George Coriatis, Valentin Steinman, Perk Rowley, Kate Von Goller, Alexander Hubbard, Liam Dunaway, BR, Masood Ali Mohammadi, Perpendicular, Jonas Hertner, Ursula Goodenough, Gregory Hastings, David Pinsoff, Sean Nelson, and Mike Levine. A special thanks to my producers, Isar Webb, Jim Frank, Lucas Stafiniak, Tom Vanagdam, Bernard Ugni, Curtis Dixon, Benedict Mueller, Thomas Trumbull, Catherine and Patrick Tobin, John Carlo Montenegro, Alnick Ortiz, and Nick Golden, and to my executive producers, Matthew Lavender, Sergio Adriano, Bogdan Kanivets, and Rosie. Thank you for all.